All right. So does anybody have any questions on the prepare assignment?
I don't.
Nope.
All right. Well, I guess we'll just get started and then we'll answer any questions we have as we go.
Yeah.
So this is the lesson 12 group meeting quiz. Okay, so let me know when everyone gets to question number 3.
There.
I'm there now.
All right. Okay, so we have to find the test statistic.
Got 2.
So you're just plugging this information into the one sample t-test for means, right?
Well, I just did the equation for t. But yeah, I guess you could also do it that way.
Well, I don't know, because I just put the information in there and it's saying negative 7.1 negative 7.091, so that's obviously not 2. So I don't know, maybe I'm doing it wrong.
So it's the formula. What do we use as the mean?
Well, at least for in lesson 12, when you go through, where is it? I'll find it really quickly. Sorry.
Oh, you don't.
So it would be
2.2.
So it's the difference minus the null hypothesis divided by the standard deviation divided by the square root of the number.
So you did like square root of 9, or I guess you did 3.3 divided by the square root of 9.
Yeah, and then 2.2 divided by that.
Equals to.
Yeah, which gives you 2.
But I don't. Let me try doing it on the Excel spreadsheet.
Yeah, I get the same thing too. But yeah, I don't. When I was putting into the spreadsheet, that gives me something different.
So if you put the exact data into the summary statistics part of it, and you put the difference in as the mean, then it'll give you the t-value of 2.
Oh, yeah. Mhm.
Oh, okay. It's because I had a null hypothesis in there that was from the previous.
Oh, okay, yeah, that would change it too.
After I zero that out, then it drops down to 2.
Okay, sweet.
All right. So number 4. So we have to use the normal probability applet for this one, right?
Yeah.
$2.051.
I got 2.256.
Wait, the probability. Oh, great. Oh, okay.
How did you get it?
Well, I don't know if I'm right, but so I just typed in 0.0403 and the normal probability applet. Got the z-score. Oh, but we need the p-score. Okay, that's probably not right. Use this probability to determine the p-value.
So in the in the at least in a reading, they use the t-score and put it in for the z-score.
So 0.0228.
Is it? Oh yeah, I got that too. 0.0228.
So that's all we do.
Do you do both tails, or do you just do the right tail when it's a not equal to?
I just did the right tail because if they're asking for if it's greater than, use probability to determine the Pierce value for Jordan's hypothesis. Obtaining a test score or a test statistic greater than Jordan's test. So if it's greater than, I think you would just do the one side, right?
And what's your formula for that, Chris?
Austin was saying to put the T value as the Z score. So that's what I did. I just put 2 as a Z score and then shaded in the right tail, which gives you an area of 0.0228.
Point 0228.
Yeah. Oh, so round to the third decimal point. So I guess 0.023.
Yeah, 0.023.
Okay. Well, is everyone okay with that answer?
Yeah,
Yeah.
I'm a little confused by the question. Yes. Like, are we supposed to use the 0.0403 in something?
That's what I don't get. Yeah, is we didn't use that anywhere.
Well, could we? I don't know.
Oh, wait. So, since the probability is 0.0403, oh, actually, I don't know. Okay, so when I put in the values into the Excel spreadsheet on the paired sample t-test, and when I changed the type of test to greater than, I got the p-value of 0.0403. So Are we supposed to, I don't know. I don't know. This is kind of a confusing question.
So it's saying the Excel spreadsheet is saying that the p-value is the same as the test statistic.
Yeah, if I put in, so I use everything we did in question 3, and I just change the type of test to greater than, I get 0.0403 for the test or for the p-value.
That's a rounded value, though, right?
That after I round it, yeah, the Jordan's test statistic is rounded.
Okay, cool. I'd say because mine's like 0.04025811.
Yeah, mine's the same thing.
Okay.
So I don't know what that. Are we supposed to change it to like not equal to? I'm confused a little bit.
It's got to be. I mean, it has to be greater than. But
Oh, wait. Okay. So all these questions are based on Jordan's hypothesis things. So I guess if we change the type of test to not equal to, then the p-value would be 0.0805.
Okay.
So in question 4, it's saying that the
Oh,
p-value
no,
is
we do want greater than, though, right? Because that's the type of test it is to see if it's greater than.
well. They're saying that the probability of getting the test obtaining a test statistic greater than Jordan's test statistic is 0.0403.
oh,
And so when we change the type of test to greater than, it gives us that p-value of 0.0403 when we round it.
Oh, interesting.
And then so if you go back to not equal to, like in the right in the information right above question 3, it says that the alternative hypothesis is not equal to. So if you switch to that, then the p-value is 0.0805.
Okay, yeah, that makes sense.
Oh, yeah. Mhm.
That was a very confusing question.
Yeah. So, okay. 0.081 then, right?
Yeah,
Yeah.
at least I think so.
Oh,
all right. The next one we're going to use the data, so we can plug that in.
Yeah, I have to go to the paired sample test, t-test.
What is this?
And the confidence interval would be 0.90, right?
Yes.
Because the level of significance is 0.1.
0.10. Yeah.
Okay.
I'm always confused on what do we put it as the null? Like,
The null
Zero?
for this one is 0, yeah.
okay, that just confused me that it was 0. And then this one is going to be not equal to.
Yeah.
So the t-test I got was 0.407 for
Yeah,
the test statistic.
I got the same thing.
Yes, I got the same.
Chris, did you get that too?
hold on. I'm slowpoke here. I'm still plugging in the information.
Oh, you're good.
Yeah. Okay, so what was the question?
So we're looking for the test Man, I can't say that word today. Test statistic. There you go.
Let's see. Type of test. It's type of test is not equal to. Okay, looks like right now I'm getting 0.407.
Yeah, that's what we got too. So that's good. And question 6 is the p-value. I got 0.689.
That's what I got too. 0.689,
Yep.
which means we would fail to reject the null.
Yeah.
So we just need to change our type of test to greater than.
So the p-value is still higher than the level of significance. Does that mean that we have insufficient evidence that the mean of the difference is greater than 0?
That's what I think it'd be.
Yeah, B.
And we have to. Is everyone okay with where we're at right now?
Yep.
Yes.
Yes.
All right. Looks like we have to download the other data now.
Mm-hmm. Yeah. Oh, no.
All right. So once you guys get that, let me know what you get for number 9.
Which is greater than and
Yeah, and
Yeah, N is 22, so that's yeah.
Okay, that's what I got.
let's
And
see.
what is the p-value? Point. Oh man.
0.001.
001.
Yeah.
Mhm.
And then this one most definitely.
Reject? No.
Yeah.
Reject.
12.
So now we just need to change it to greater than.
Is greater.
Oh, mine was on greater than.
People. No.
It was still
What is-
right.
Huh.
The people.
Oh, yeah, it's still 0.001.
Yes.
Well, like, rounded.
Yeah. What is it? What was the first one unrounded?
0.0012.
So this one's 0.0006.
06.
Yeah.
So it's
So
still, but it decreases.
Great.
And it still rejects the null hypothesis.
yeah, decreases.
Okay, so we have sufficient and transcendental.
Is it C?
I think so, yeah.
I mean, it's A or C.
I think it's C.
That'd be C, right? Because we're
Yeah.
trying to prove that there's a difference.
Yeah.
So for 15, is it greater than? It gives, yeah, greater than gives the lowest, or gives the smallest p-value, right?
Graded, yes. I think.
Yeah. But why would it be like? I know that we just did that, but why would it be that one every time?
Is it
In
every
general.
time?
Well, it's just in general.
Okay. Oh, in general, okay. Well, I don't know, then it'd be not enough information. It depends on the problem, right?
Let me see in the reading if it comments on this real quick.
Depends.
I mean, to me, it just wouldn't make sense why the p-value would, because it would just depend on the, because you could have a large p-value with it being greater than.
Yeah. So it's got to be, well, it has to be then that there's not enough information because we don't, it really depends on the data points, right?
That's what I think.
Unless yeah, because I think if the mean differences are negative, then it would change based off of that.
Is everyone okay with putting not enough information?
Yeah.
Uh,
Yeah. Yeah.
Okay.
Okay, so now we need to do a 0.95 confidence interval.
Fine.
What are you guys getting for this one? The point estimate. Is it that one that we have to calculate?
This is last week's, wasn't it? I don't remember.
Yeah, it was.
Okay, yeah, so the point estimate is the,
Whatever.
oh wait. So the point estimates can be a lot of things. That's what I thought it was. So the point estimate is like the sample estimate for either the mean or the standard deviation.
The sample mean difference.
So it can, I don't,
so 11.95.
I think so.
yeah, I guess we can probably do that. That would make sense. But I don't know if it could also be standard deviation.
Huh.
Because in last week's, it talks about the point estimate of standard deviation is the sample standard deviation.
Mm.
Yeah, it says to construct the confidence interval when sigma, I think it's sigma is not known, we replace the population standard deviation with its point with its point estimate S.
Yeah. But then if you go back to lesson 10, there's a chart that shows all the point estimators, and it can be the sample mean, it can be the sample standard deviation, or the sample variance. Those are all point estimators.
Mm.
Well, we do know sigma, or we do know the level of significance. Is that what it is?
Yeah.
Oh
Well,
wait, no, it's
the sigma
standard
is,
deviation.
yeah, the sample standard deviation.
Do we know the sample standard deviation?
I think it's under the it's right next to the mean in the chart.
Okay.
Oh, look up in the information. It says determine the 95% confidence interval for the mean difference. So it is talking about the mean difference.
Okay.
Yeah.
Oh,
So
yeah.
so 11.955.
Okay. And then,
Do we round to 3, I guess?
yeah.
Yeah, it doesn't say, but I think that's the normal.
Okay. Then margin of error. So it's not the standard error of the mean. I don't think.
So then we have to, for the margin error, we'd have to do point. If we wanted to calculate it by hand, it would be point or 1.960
Times.
the standard deviation divided by the number of the square root of the number of samples. So it's 22 squared. And
Are we using the difference standard deviation?
yeah.
So 15.003.
So then for the margin of error, I get 6.29.
Yeah, that's what I got too. 6.29.
Okay.
Should we round to 3 decimal places?
Yeah. Wait, it's 6.269?
Yeah,
6.269.
6.269.
And then the lower bound of the confidence interval is 5.303. And the upper bound is 18.607.
All right, who wants to submit theirs?
I'll do
You guys say you got for 17. I was trying to figure that one out and then I got lost.
Okay, so 17. You just do.
it. Oh, 17's not right.
Oh, it's not right.
So
Okay.
maybe we should do the
Is
what's the
it-
margin of error?
Is everything else right?
Yeah, everything but 17's right.
Okay. Well,
Is it then such some? Should we just do 3.199?
let's see. Let me go back to lesson 10. Oh, because we have to do. Don't we have to do 2 times?
In lesson
Oh, wait.
10.
Because in lesson 10.4 says, notice that when we know sigma, then or standard deviation, then with approximately 95% confidence, the mean will be between the following 2 values. But we would need to do 2 times. Because the margin of error is 2 times the standard deviation over. Okay, hold on. Oh, it's because it's okay. We did it a little bit wrong, I think. 0.003 divided by the square root of 22. Oh, wait, I got the same thing. Oh, wait, that's because I'm not doing it times 2. So is it 6.397?
Hold on. I'm crunching the numbers right now.
Because this is a 95% confidence interval, right? Yeah. I'm going to try this one.
What formula are you using?
So I used, in lesson 10, it says the margin of error is 2 times the standard deviation divided by the square root of n.
Mm,
And it'd be 2 because it's a 95% confidence interval.
yeah.
Oh, whoops! I had myself muted accidentally.
Oh, so wait, which one was it that we missed? Oh, 17.
17, yeah.
Yeah, okay, it's not 6.397 either.
Okay, I'm getting 6.269. Yeah, because we're gonna try the 3 spaces, right? So 6.269.
That's what we put in the first time.
Oh, whoops.
But that was the margin of error, but it might not be the right one. Somebody want to try 3.199?
3.199.
How'd you get that?
That's just in the standard error of the mean.
Oh, man, that'd be so lame if that was it.
Yeah,
I bet you it's it though.
it probably is.
Huh. I'll give that a try.
Okay.
But that's weird though, because then don't you have to times it by 1.96 because it's a 95% confidence interval?
Yeah, I don't know. Let's just try.
Yeah.
Wait and see.
So 3.199. Okay.
Actually, I'll be right.
I'm wondering if we're getting something wrong before that point.
No, everything else is right except for that.
No, but I mean,
You guys think we're supposed to use 15.003?
I don't know.
I just put 15.003 over the square root of 22.
But
And then-
maybe we're not supposed to use 15.003. I'm gonna look at the question again.
Because the standard deviation they use in the margin of error is for the population standard deviation, where this is a sample standard deviation.
Doesn't find the mean difference. So 15.4.
Let's see if I can use, I can get the margin of error. And so,
15.4.
wait, can we use the confidence intervals to get the margin of error?
That's why I'm wondering if we should replace 15.03 with 11.955. Is that what you're saying?
Oh wait, sorry. What'd you say?
Should we be replacing 15.003 with 11.955?
I don't know. I don't know at this point. I don't know.
Because if it's, so determine the 95% confidence interval for the mean difference, and we got that one right. So I don't know if it's talking about margin of error for this 95% confidence interval. I don't know. I'm just wondering if we should replace the 15.03 with 11.955.
I mean, you can try. Have you tried an attempt yet?
No, I haven't submitted yet. You want me to give that one a try? Let's see. Man, I don't know. That just seems to make sense because usually we use, information from the problem before, right?
Yeah.
I mean, if we're coming up wrong so far,
I just don't know what other options we have. This margin of error question is one that I missed on my test last week.
Ay, Melissa.
okay, I'm getting let me try that. I got 4.996.
Did you use 15 or 7 or 16?
I used 11.955.
Oh,
Well, no, am I totally like off there? I don't know.
wait, where's the 11 from? Is that from the
Question.
that's from the question?
So it's saying determine the 95% confidence interval for the mean difference between the two groups. And then question 2 input. Okay. So if we got 11.955 for the point estimate, the 95%, I don't know. Am I just, what is the margin of error for this 95%? I don't know. Maybe that's not the way to go about it.
I have no clue.
It just doesn't make sense because it seemed like we used the right formula with the right numbers in there.
We've never got less than 100.
Oh, okay. So apparently you can, to get the margin of error, you can do the second confidence interval minus the first confidence interval divided by 2. Let's see. Try 6.652.
6.652.
Yeah.
Okay, you want me to submit that?
Yeah, try it.
All right. Okay, that was it. We got it.
Wow.
There you go. Thank you, algebra.com. I wonder what way we're supposed to do it though. Does anybody know which way we were supposed to calculate the margin of error?
So what did you do? You just took 18.607 negative 5.303 divided by 2?
Yep. And it gave me 6.652.
Well, all right then.
Yeah, because it doesn't talk about that way in the book.
Yeah, I don't know, because all the ways it talks about margin of error, they're asking for values that we don't have. That was interesting. Okay, sweet. Well, at least we got it in the end.
Thank you so much.
Yeah,
Thanks, everybody.
good job, Austin.
All right. Well, thanks for coming, guys, today. Thanks for also being able to do it at 5.
Yeah,
Yeah, no problem. That worked out great for me.
yeah, pretty flexible.
All right. Well, what time are we meeting on Wednesday?
Whenever everybody is good to meet, I am okay.
Yeah, whenever.
4.
4?
Does 4 work for everybody?
4 is
Everybody
fine
do
with me.
4.
4:30.
Is
All right.
4:30?
Okay, we can do 4:30.
Okay. Yeah, I can do 4:30.
Okay.
Yeah.
You guys are talking